There are two kinds of DBAs, one who are taking their backups and the other ones who are planning to take their backups, and those are the ones that always face issues when the actual situation occurs. So me being a part of support, we do have several customers reaching out to us that I have a kind of backup, but I want to go back and restore some tables or some corrupted data, and I want to restore it from backup, but he doesn't have the right kind of backup. So just having a backup doesn't help. You also need to understand what kind of backup will help you restore what kind of data, right? So you might need to restore multiple things from your cluster, and what kind of backup will help you restore what kind of data is very important. So backups are important because there are several application issues that might happen. There are several, so we have several users who connect directly to the database cluster in order to run several queries. Issues can happen with that, and then there are several web attacks nowadays that happen. We try to keep our servers as much safe as possible, but then there are situations that happen, and losing all the servers highly unlikely, but I have seen that happen when the servers are in a certain building that catches fire, or they get submerged in water. That has happened. Customers did face these issues, so that's possible. So what do we expect to recover from backups, right? So that's the key factor which we need to understand before we start planning for taking a backup. We might need to restore just a table. We might need to restore a database, and we might need to restore a complete cluster. So in Postgres, a cluster can have multiple databases, right? So you might need to restore individual database, or you might need to restore the complete cluster. So these are the three things which you can be expected to recover from any situation. So we have had several customers who have come to us that they do have replication servers, right? So they don't need any backups. They have multiple nodes, 4 nodes, 5 nodes, 6 nodes, right? They have the database in the cloud. It's highly impossible for that to fail, right? So those are the kinds of customers who face situations, because as in the previous slide, if a user accidentally truncates the table, right, that replicates as fast as you can blink your eye. You might have 6 different replicas, but that table is gone from all those clusters. So that's why you need to understand that you need to have both the backup as well as the replicas. Replication is usually for high availability where your hardware fails, right? It doesn't safeguard against loss of data from a user error or from a corruption, right? Corruption also replicates from one server to another. So you have to understand that's why having a backup is very much important.
Data is getting replicated. So in that case,
so how does the data replicate? So data gets replicated as soon as something is written to the master, right? Any action that happens on the master is replicated, right? A user accidentally runs a command to truncate a particular record or a particular table. What will happen? It will replicate. How will you recover from that? Right? So you will need to have some kind of backup in order to recover from that.
Okay.
Right? So if he deletes a table, right, so you have no backup, then obviously you cannot recover. But if you have a backup from yesterday, you might be able to recover at least 1,000 records out of 1,010 records. You might just have to recreate those 10 records, right? So having a backup is very important. Okay, so again, the replicas cannot recover from any kind of data loss from a user error or from a corruption. So replicas cannot take care of those two particular things. So the options that are there in Postgres to take the backups, the logical backup, which is basically the data, the structure. You have pgdump utility, which gets installed along with Postgres. For physical backups, you can have PG based backup, which takes the backup of the entire data directory, or you can have file system level backups like net backup or anything else which you might be using, right? So you can have a complete snapshot of the disk itself instead of taking everything separately. So again, it depends. The cost effective part depends on what you might need to recover and how fast you might need to recover. So we'll have a look at in the next few slides. We'll have a look at what our options are available, which you can recover from PG dump, and which options you can recover from PG based backup or file system level backup, and how fast that can be, right? So that will depend, and again, your business requirement clubbed with that will help you understand which will be cost effective for you. So that's where the planning part comes in. So you need to have all the options, then you need to plan for the cost of each option. So the cost is not only the hardware cost, it's also the cost for the time lost in recovering, right? So you have to take into account that as well. Okay. So PG dump, that's the primary tool for taking the logical backup, right? It runs like a regular PostgreSQL session. It connects to the database server, and then you can get a consistent snapshot of that particular database for the time you started the backup, right, of the PG dump. It's multi-threaded now. So in multi-threaded in the sense that you can, the threads can take care of multiple tables. So one thread per table is what multi-threaded means. In case you have a huge table and the rest of the 10 tables are pretty small, those 10 tables might complete in a couple of minutes, but if you have a huge table of a couple of 100 GBs, that will take its own time. So you need to understand how much time that takes, and that will be your actual time of taking the dump. Okay. So the dump can be in plain text file, and it can be in compressed formats as well as custom format, right? So there are multiple options available from which you can recover. So we'll understand that. How will the plain text help, right? In case it's just a table or a structure of a table you need to recover, plain text you can just write a script or do a search manually and recover that. But from a custom format, you can extract the complete data of a huge table, recover it. Okay. So the custom format is compressed by default. So it can dump individual objects. So you can have the dump of the schema, dump of just the table, or just a database. So you can have different kinds of dumps with PG dump. Taking dumps individually is not that much helpful, right? So having a full backup always helps. So you can, in certain situations where you want to dump and restore it to a QA setup or a test setup, individual dumps might help, right? You want to do some testing on a particular procedure with just a single table, that kind of dump might help, but having a full backup definitely adds value. Performance impact, since it's a copy command that runs in the background with the PG dump, it doesn't have that much performance impact on the server. So there's one single backend table, as I told you. It doesn't use Postgres cache because it reads from the disk, right? So that's why in the negatives, the I/O of the disk increases. In case your application or your database is I/O intensive, then it might just hamper your operations. Number of objects will also be a consideration, a negative effect. As I told you, even if you have 10 small tables and one table is pretty huge, that particular table will impact the performance of the PG dump itself and the time it will take or the I/O it will make on the server. So that's where the considerations need to be taken while using PG dump. PG dump all. So it's a two-step process. First, it takes the global objects, that's the catalogs of the Postgres, and then and the schema as well of the tables. Then it takes the dump of the data separately. This helps in case of selective restores, right? And the SQL, it's in a SQL file, so you can have table definitions in case you have made table spaces as well, right? So it takes care of that as well. The utility to restore PG dump is PG restore. It restores full databases, so it works at the database level, not at the cluster level, right? So it restores the complete database It also allows limited restore of tables and schemas, right? So in case you want to extract a particular particular table from the dump that you have taken, there are options available for that. Again, because PG dump uses copy to extract the data, it uses the same mechanism, copy it back to the database server. So first it copies, the steps are, first it copies the data, then it creates the indexes on that, and then it creates the constraints on top of that particular table or the data. For again, the same thing goes if it's a huge table or huge database. Since it's a copy command, you can tune it up to some level, just like you tune the SQL queries, but still it's pretty slow in case you have to restore a complete cluster or a complete huge database. So that's where the physical backups come in, right? So in case you have couple of 100 GBs of databases, right? Data directories in couple of 100 GBs, and your IO, so your transactions are pretty high at a daily level. That's where the physical backups come in. They don't involve any query on the server, so they don't impact your operations. But the challenge with them is that you need to, while trying to restore, you need to have the same kind of OS architecture. So if you are taking from CentOS 6, it has to be CentOS 6. The Postgres version has to be same. The directory structure, including the table spaces, have to be the same. Then the compile flags, in case you have compiled from the source code, the Postgres database from the source code, then it needs to be with the same flags in order to use that particular backup. And again, since it's not logging into the database or running any SQL queries, it allows only a full cluster level backup. So you have the backup of all the databases in one go. Okay, so two types of backups you can use, the offline, so you can shut down your database. You can either copy the database data folder, or you can take the snapshot of the whole disk itself. If you have it in cloud, they have multiple options to take the disk level snapshot. So that helps, and that's much faster than copying the data folder to another disk, right? So any file copy mechanism, so net backup and couple of other OS level utilities are available for taking the backup of the disks. So you can use any of those, and if they come with any compression levels which can help you compress the snapshot, that can be used as well. So file system level snapshot, so you can also take the snapshot of a running cluster. You need to put it in a backup mode, right? So PG start backup, then your backup label is how you put it in a backup mode. You can continue your operations, and then you can take the snapshot. The snapshot will be from the time you have started the PG start backup command, right? So the snapshot will be consistent up to that point. After that, you will need to include the WAL files to make sure you are able to recover up to that point, right? So you start the backup, then you stop the backup. You have that, you archive the log files. Between these two, you will have a complete information to restore the cluster, right? We have so in case you do not put it in the backup mode, since the tables will get modified at the back end, you will not have a consistent snapshot of the data directory, and you might have issues restoring that. So make sure, so customers do miss doing a start backup and a stop backup. So make sure you plan for that. You have a script, or you have a charter to steps to make sure that that gets taken. Yes. I'm missing that, but yes, you can do it. I think in PG version 10 or 11, there's an option. I can check and get back. Right. So incremental backups, there are utilities available, right? So incremental backup, basically you can take care of take the backup of the WAL files, right? So you have a full backup on Monday. For the rest of the week, you take a backup of the WAL files, and then you can club it and have it a one full backup of the week, right? But there are so there's BART, and I believe Barman also has the option of taking incremental backups. So, you will have to use some kind of utility. Sorry? Native side we don't have. Okay. So, having a backup is pretty good, right? But again, as we discussed, what we need to recover is more important. That's what we need to plan. Planning a backup only does not help. Sorry.
Yeah, do you have some insights on what actually PG start backup does? How does it ensure consistency? I mean, what happens to the writes? Are they just written to write-ahead logs or not written to a database then?
No, I don't have that insight, but I can get it for you. But
Okay,
yes,
so-
I think it puts, it doesn't write to the disk files, it keeps on writing to the wall files.
Okay, so that would cause the write-ahead logs to bloat. So
Yes.
you cannot run it
So-
for
so,
long. So
yeah.
taking a disk snap, taking a file system backup while running PG start backup, and the file system backup might take too long because we might have say too many table spaces. Then that probably not be a very good idea.
So, even if you do other kinds of backups, you will still have the same problem if the space is large, right. So, you need to understand how much time it will take. You can do it in parallel. You can have parallel threads for doing the table spaces along with your data directory.
Okay.
Right. So that's again kind of business requirement. You have to understand, analyze which plan will best fit you.
So currently what we did was we have a backup replica and we stop the backup replica, the Postgres instance. Then we take a file system snapshot and then we restart the replica and it takes
Right.
the write-ahead from the archive. But again, that's something very expensive because you have to have a replica just for the backup purposes.
Well, it's not just for backup. You can use it for as a read-only replica as well.
We can
so
use it
perhaps,
as, we can use it as a read-only replica, but then again the Postgres has to be stopped for some time while the backup is being taken.
Right.
So no reads would go through that time.
Right.
So there's that. Okay. Thank you.
So how recovery works is what we need to understand, right? Restore and recovery works on the same principle. Whenever Postgres starts or restores, it starts with a consistent checkpoint, and then it starts reading from the wall files. From the point it finds a consistent checkpoint. The files need to be, the files are written to the PG wall, PG xlog or PG wall directory, depending on the version. Each change, everybody understand that each change made in Postgres is first written to a wall file. The settings that are required, minimum settings that are required are archive mode and archive commands to ensure that your wall files get written. Then each wall file, once it's completed, is checked for consistency using CRC checks. So once a wall file is written, we can use it to apply from the checkpoint, read all the changes that have been made, and then apply it to recover or restore. So both work on the same principles. So even if you have a replica, it works on the same principle. It uses the wall files to make sure that your replica is your replica reads the wall files and then comes up to the latest point. So the options available to recover table, cluster, or database. So a table can be recovered from PG dump, a custom or a plain file text dump, right, as well as a PG based backup. Database again can be recovered from a custom format of the dump or a plain file text backup, as well as PG dump all option. Then a cluster, for a cluster level restore, you will always need either a file system level backup or a PG based backup. How things work? So recovering a table. So if you have a PG dump with a custom format, you can extract the table that has been dropped from using the PG restore utility in a SQL file. Then you can simply connect using the PSQL and restore that. You have to make sure, since you are trying to restore, that the table does not already exist in that database. From a physical backup, again this is costly because you have to restore the whole cluster. Sorry. So you restore the whole dump, you start a new cluster, you use a PG dump to dump that particular table, then you can use parallel jobs to restore that particular dropped table. So, in this case, restoring from a physical backup is much more costlier because you will need to start an entire cluster. So, you will need to have a complete server available, the same RAM, same configuration available, and then you can restore you can extract the table and then restore it. So, in this case, your PG dump backup would help, as it will be much faster to extract from that. Okay, recovering a database or a cluster, again from a custom dump, you can extract the database that you want. Again, it's PGConf files, so you can tune your database for recovery. You can increase the required memory parameters to speed up the recovery, and then each database in the cluster still needs to be recovered separately. So, in case you need to restore the whole cluster, you can the fastest way to do is from the file system level backup, right. So, copy the dump data directory to a new folder, simply modify the permissions, and if you have all the binaries which were the same or compiled using the same flags, you can simply start the server and you will be up and running in no time. So, in this case, recovering in this case for a complete cluster will be much faster than recovering using the PG dump. Yeah.
You said we can use some memory parameters to make it faster.
Right. So, work mem, shared memory, right. So, simple way, the same way you tune it for your queries in Postgres. So, you can use the same kind of tuning parameters for that, because it runs the SQL queries copy command in the past to load the data, right. So, you will have to tune the same way you will tune the SQL queries.
Excuse me. So, if you are using a barman as a solution for the backup, so is there an option of restoring a particular table using barman?
I have not used barman. Okay. Another important point is to do the point in time recovery, right. Every time so not every time, so somebody accidentally drops a table, right. You already have the table has been dropped from all your replicas. You will need to go back and recover that particular table. So, for that you have to ensure from the beginning that you have the archive logs, all the WAL files, then you have a full database backup, so retention is also important. So, you cannot say that I just dropped a table and I took a backup right now and I will be able to restore it to a previous point. The WAL files is write ahead logs. So, you can only move forward from your checkpoint to and start applying the WAL files. You cannot go back in time. So, you have to make sure you have a backup of the previous day at least. Then you can understand what time the table was dropped from the log files, and then you can do a recovery an hour or 30 minutes before that. So, you have to make sure that you are prepared for that. So, what you have to do, you have to again extract all files from the backup, restore it on a separate server, use the pgxlog folder, and then in the recovery.conf file, besides the rest of the parameters, you have to give the restore command, which is already there, and you can use the recovery target time. So, usually in order to recover to the latest point, it's used as latest, but in case you want to recover to a point where the table was dropped an hour before that, you can use that particular timestamp to recover that particular table. Yeah.
Is getting removed, right?
Sorry?
Recovery.conf in the Postgres 12.
Right.
So, will these parameters will be available in the Postgres.conf again now?
No. So, recovery.conf is a separate file. It's usually there on the slave server.
True, but in the Postgres 12, this file is getting removed, right?
Right.
So, these parameters will be incorporated within Postgres.conf for the standby also?
Yes. Yeah. Okay. Sorry. Yeah. Postgres 12. Yes.
Yeah.
Right. Sorry. Yeah. Okay. So, once you have the recovery.conf ready, you can simply run it. It will recover up to that particular time. you will have the table. If you have you have created the setup on a test machine, you can dump the table, restore it to your production backup, or you can use this in case there's a huge gap in the data between the production and the backup that you had. So pros and cons of the logical backup. So logical backup, single database backup is pretty easy. It's very fast. It uses copy. It dumps all the data. No separate files are required. So no walls or nothing else is required. It's cross version compatible, so you can dump from 9.3 or sorry 9.4, 9.3, and then you can restore it to any version which you want. You have to make sure that the PG dump utility that you use to dump the data is for the version that you are going to restore. So if you want to restore from 9.6 to 10, make sure you use the PG dump from version 10. You dump the data and you can use the PG restore from 10 to restore it to a 10 server. So this way you can also do the upgrades. The cons, no PITR because it's a SQL file. So it's a snapshot of the current status of the server of the time you ran the PG dump. So in case something has been dropped, something has been corrupted, no PITR is possible. Very slow to restore in case of a big database or a big table. It's prone to locks and waits. So while taking dump, it's possible that your particular table is busy. So it still needs a soft lock. So it might keep on waiting for that. Extra effort is required to restore in the sense that you still have to extract the relevant data you want to restore. In case you want to restore a table, you will still have to extract it from the PG dump and then restore it to the database that you want. Another thing is that you have to back up the global objects, the catalog and everything separately, and you have to take the database, data dump separate, data from the table separately. SQL statements are executed, so again very slow because of that. Pros and cons of physical backups, no locking or waits. Since it's a file system level backup, it doesn't hamper any operations of the database server unless you are stopping it and then restarting it. An entire cluster is backed up at one given point of time. It's an almost instantaneous restore in the sense that you can simply ensure that you have the right kind of binaries available on a secondary server, and you can start those binaries and it will read the data, point to the data directory with the correct permissions of course, and you will have a running server with the same data available to you. PITR capabilities are possible with a combination of the backup and the WAL files. So PITR is only possible if you have the right WAL files available with you. So it has a dependency on binaries, so you cannot have a backup from a version 9.6 and restore it to version 10. Very large backups because you have to make sure that you have the WAL files as well. So having just the PG based backup or PG or a snapshot doesn't help. You have to make sure that you have all the WAL files available in order to make sure you reach the latest point of the database server. Again, I need to archive the WAL files. So you will have to just not store the database backup. You will also have you will also need space to store all the WAL files from the point the database backup was taken. Very high I/O because again it reads and writes, right? So it reads from the disk and it has to write from the disk. So no Postgres operation is no internal Postgres server operation is done. It's all at the OS level. So the I/O is pretty high. Yes.
Yeah, I was saying WAL archival is quite different from the Postgres backup. So what if we have a logical backup, we have a PG dump, and while starting the server, we have a recovery.conf that get the WALs from the WAL archive. So
you cannot start a server from a PG dump, right? Because PG dump is taken in either a custom format or a SQL file. So you will have to first restore it to a server, right? And in that case, timeline will change, the WAL files will change. So you will not be able to apply the WAL files.
Okay. Okay.
Okay. So size does matter. This is just a basic guideline. This is not hard and fast. So, small databases, it's advisable to keep both kind of backups because you will not have use that much space, right. So, anything up to 50 GBs, you should take the PG dump as well as the file system PG based backup. So, you file system level backup, because it will make sure that you have all the options available to you at the end of the day in case you need to restore anything. Anything in 100 GBs, again depending on your cost and the resources available, both kinds of backups. If not, then physical backup is much preferred. Reason being, you can still take the PITR, you can restore it, you can extract the tables, you can extract the data. So, you have all these options in case of a physical backup. For databases larger than 500 GB, PG dump will simply not finish. So, go for the file system level backups.
Hello?
Yeah.
I have one question actually. Currently we are using the fetch mode for taking the daily backup. For streaming replication we are using the stream mode. So I would like to know, is it possible to take backup in stream mode for daily backup? And what is the difference between the fetch mode and stream mode? Can we take daily backup using stream mode? And can that be used for restore in future? So basically, in short, the difference between fetch mode and
so
stream.
I don't in my experience, I don't think that there is any difference in the fetch mode or streaming mode. It's just that in the back end, which server will get more busy will depend on which mode you use, right. So, because you are only using fetch or the streaming mode, you are still getting the WAL files.
Okay, so there shouldn't be much difference, right?
Yeah. So, in case your primary server is pretty busy, a fetch mode helps, because in fetch mode your slave server will be requesting for the files, right, will be doing most of the operations. In case of streaming, the primary server will have to stream the files. So, that is where it will make the difference.
Okay, so will there be any difference in backup time?
I don't think so. I am not aware of any difference. Right.
Thank you.
Right. So, it's see. It will get replicated. It will definitely, because it will replay the same thing.
Yeah, as per my understanding, streaming when we would take PG based backup in stream mode, so it will apply the WAL files. It won't just fetch and keep. If you're using fetch mode, it will fetch the data. Fetch the WAL file and keep it. But if you use stream mode, it will actually apply the WAL file. Yeah, I understand that's about streaming replication.
Okay. So, let's take it offline.
Yeah.
Right. Thanks.
So we'll keep it.
Okay. Right.
Please go ahead.
Yeah. So, frequency once a week at least, again depending on how much writes happen to your master server. So, in case you get a huge data on your master server in a single day, then you need to change it to a day. Again, you have to think how much far back you want to go, right. How much time it takes to backup and recover, you need to plan that as well. If you are taking a PG dump, it might take you 6 to 7 hours to take the backup, right. So, that might not be possible every day, because it will also add load to your master server. So, you have to take that consideration into planning. So, as we said that there are a couple of utilities available to do incremental backups, have a look at that as well. But again, that will also add to space once you start having incremental backups. Plan your restore. So, again, not just planning the backup, you can have the backup any which way you want. Make sure you plan the restore. You should test it, because unless or until you are able to restore in a time which is feasible or conducive to your business plan, having a backup doesn't help. restoring it over 4 days will not help your business. So make sure you are able to check the time it takes to restore. Again, that downtime should be acceptable to your business requirements. How far you might need to restore? Again, you cannot go cannot go back. You can only go forward. So how much times data you might need to go back to is the time you need to keep the wall files and need to plan for that. So you make sure that you have that planning done. Always test your backups. All of us take backups, and hardly anybody of us takes some time to check those backups. There is no way in Postgres to check the consistency of a backup unless or until you restore it. There is no utility available to check whether your backup is valid or not, unless it starts up and you are able to connect to the database server. You need to find the recovery time as well. Make sure you practice restores, right, so that you understand how much time increases as your data increases, and document everything so that if you are not there, the other DBA can understand where the backup is kept, where the wall files are there, how much time it will take to restore, and what all permissions or other changes that he needs to do in his environment. And I think this should help. So, anything else? Okay. Thank you.
Thank you.
Thank you.